Just setting the background scene for why we need to decarbonise our heat grid, which is because we've actually agreed to become carbon neutral by 2050. And to achieve any sort of carbon neutrality, we've got to come off of our carbon-based heat diet, and that means everything needs to move to electric. And I'm just going to take you through what that really means in some sort of reality check. So this is a great little website if you're into such things, called GridWatch, and it sort of updates every 15 minutes, I think. So I went on there this morning and took this screenshot, and it just shows you what the demand is today and where power's coming from. And we've got around about 8% renewables, 5% nuclear, 16% gas, nothing in coal, and we're importing some as well. So I just think it's really useful to know roughly what sort of breakdown you got, and you can go on there anytime. So it's a really nice little website. And if we have a look at the domestic heat use, you can see that pretty much 90% of all heat demand is covered by carbon-based fuels in this country. Around about 10% is covered by electric at the moment. And, you know, based on looking at emissions, around about 11% of all our carbon emissions come from buildings. So it's actually, well, come from domestic buildings. So it's actually quite a big percentage of our carbon that we emit, and that we've got some control over here. There's around 27 million homes in the UK, and 25 million of them need to be retrofitted to some degree. Now, some of them might be a B already and could get to an A with certain bells and whistles. Some of them will be an F or a G and really need a big overhaul to improve them. And then, of course, we've got a lot of buildings, especially in Bath and Bristol and lots of other country, old towns and villages that are listed, and it will be challenging to improve the energy efficiency of those. So where we can do it, we really need to do it, because we can't do it on every home to an A standard. And this is just a nice little graphic that shows where we use energy in the home. So there's around 65% of our energy needs in the home are space heating. That is the single biggest use of energy in our homes. And around 15% on water heating. And then we've got a few other things for electricity, appliances, cooking, that sort of stuff. So that's like a whopping, what, 80% pretty much that comes from, generally speaking, carbon-based fuels to heat our hot water and our heating, based on that previous graph. So, you know, that's actually a fair chunk that we've got to convert into electric energy to provide the heating that we're used to. So in the UK, over the last 40 years, the UK residential emissions have actually grown, even though we've had an energy efficiency sector all of that time. That's partly because we've had a massive growth in population, and it's partly because most people are living in smaller households of 2 or 3 or maybe 1 person. And also people are used to heating their homes to a higher temperature. So that has partly been the growth. But during, you know, the period 1990 to 2017, the average SAP ratings, that's what's on your energy performance certificate, they've increased by 20 points. So whilst we're going in the right direction, we are making improvements, we're also taking gains, and we're really not moving forward quickly enough to achieve the 2050 target if we're only going at the same rate from now on in. So to achieve an 80% reduction in CO2 emissions, we need to retrofit about 500,000 homes a year. If we want to achieve carbon neutrality, we need to do more, and that's a really significant amount of homes that need to be retrofitted. And I might hear you say, well, hang on a minute, why have you brought retrofit into the question here? And the answer is, we need to decarbonise the supply of heat, and really the only way you're going to achieve that properly is by retrofit. So in the owner-occupier sector, the most common reasons for doing home improvements are to reduce energy bills or make the home warmer, particularly in winter. Obviously that is after moving in, redecorating, putting a new kitchen and bathroom in, but generally speaking, that's why will people spend money on their homes. So there's definitely a case for retrofit, and there's definitely an appetite out there. And we'll go through and just talk very briefly about future-proof. So this is one of a pilot of 6 around the country that's been funded by the Department of Business, Energy and Industrial Strategy. It's a 2.5-year programme. We're into our 3rd year at the moment. We're focusing on what the government likes to call the able to pay market. That's probably most of the people joining this webinar. If you're not in receipt of benefits, then you are probably considered able to pay even if you don't have any money. Our focus is on the west of England area. So if you happen to live in one of the 4 unitary authorities that make up the west of England and you're interested, there's details at the end of this slide pack. And we're focusing on what the government likes to call the RMI sector. That's the refurbishment, maintenance and improvement sector. And actually these are the sort of people that we employ to do extensions on our homes, put a new kitchen in, put a new bathroom in, maybe do the flooring, that sort of stuff, general builders. So, you know, that's a really important sector to work with. They actually don't really know that they're part of that sector to change our housing stock. And what we're really doing is looking at this as a whole house-based approach to retrofit, which I'll come on to very briefly a bit later. But fundamentally, what we're looking at is what is appropriate for the people that own the house and live in it, and where they are in their life, and what their budget is, and what their level of disruption is, and what they're trying to achieve, and what's appropriate for the house, because what's appropriate for an 1870s house might not be appropriate for a 1980s house. So we do need to consider that when we're looking at advice on this one. Just very quickly, this is our take-up sort of inquiries. Up until June this year, we hadn't done any marketing activity, so I'm kind of pleased with these figures. They're really low, but on the whole, I'm very happy with the upward trajectory of people coming through and inquiring. So, you know, there is a market for people to retrofit their homes and improve the energy efficiency of them, and this is all around the decarbonisation of heat. Fundamentally, we take this reduced demand approach. So in terms of my other speakers might have a different opinion, but as far as I'm concerned, the best approach to move into low carbon heat is to make your home as energy efficient as possible and as airtight as possible. That will reduce your demand for heat. And if you then install a low carbon heating system, you can have a lower base system that will heat your house better, rather than oversizing while you don't have a very airtight or well insulated home. And then potentially you might upgrade the thermal aspects of it, and you're going to have an oversized heating system. So that's the kind of hierarchy of how you would go about doing energy retrofitting. And I just wanted to put this up. It's taken from the Bristolian's Guide to Solid Wall Insulation, and I just think it's quite an interesting one because the yellow bar graphs demonstrate the heat loss for 5 different typologies. So, you know, there is kind of no one size fits all when it comes down to this. As you can see, certain types of houses have a greater heat loss than others. If you're a mid-terrace with no annexes, then actually the heat loss is quite low. But, you know, it's really important to understand heat loss, where you're losing heat, tackle it from a fabric first approach before specifying a heating system that may, you know, as I said, be undersized if you haven't got it set properly, or become oversized if you improve the energy efficiency. So part of our project is to help build a sector of builders that can do really good retrofit for customers. As I said, most of our builders that are working in this sector are micro SMEs, maybe 2 or 3 people working together, a bunch of subcontractors. They don't actually know they're part of this low carbon revolution. They're just very busy getting on with work that people want doing on their homes. We've talked today with some of our future-proof associate builders that have been doing the training with us, and they're not even aware that the Green Homes grants were released recently and that potentially they could be delivering vouchers for customers to improve the energy efficiency of their homes, and they're really engaged in our program. So I guess there's a hell of a lot of builders out there that aren't engaged that much, that would know potentially even less. But generally, this sector are really busy. They've got a lot of work on. They don't really need to learn new technologies and new ways of building or understand building physics to do it really well. When we have a look at building control, there's less regulation around that. It's not enforced in the way it used to be. Pretty much you can set yourself up as a building company if you want to tomorrow, if you've got a van and you want to put a label on it, and as long as you haven't gone bankrupt, I think that's the kind of limit as to what you're required to do. And we as consumers quite often want to go with the lowest quote because it suits our bank balance best. I'm not advocating that the highest quote is always the best, but you know, sometimes the lowest really isn't going to give you the solution that you're looking for. So we're part of that problem. So these are some of the issues that we're facing in trying to engage contractors to come and get some extra training to really understand how to do quality retrofit work, energy efficiency work that doesn't have issues for the occupants of the house and doesn't cause any issues for the integrity of the house in the future. So what we're trying to do is really, lots of people talk in this sector about, oh, I'm going to upskill all these builders, and I'm thinking, well, they've all got better skills than me at putting plaster on the walls and building walls and, I don't know, putting electrics in. So I'm not really upskilling them on those things, but what I want to do is transfer some of my knowledge around the principles of building physics and a whole house and fabric first approach and how things interact in a building. So if you do one thing, it's likely to have an impact somewhere else. Most of us as occupants of houses aren't really aware of that either. So a lot of our behaviour can exacerbate problems, either existing ones or potential ones in the future. So we're trying to help our customers and the builders understand this a bit better. So we take a whole house approach, a fabric first approach. So we look at the whole house, we try and put it in balance and keep it in balance. And then we try and improve the fabric of the building before we look at renewables or heating systems. Some of the fundamentals in this area around building physics are looking at thermal bridging, ventilation, air tightness, and the types of materials that are appropriate for the use where they're being. Much more widely in the industry for any energy company obligation type work would be the use of the PAS 2035 certification. I'm sorry, there's lots of acronyms. And I don't know what PAS stands for, but it's a standard that's being used. So you can have a look online for that. And fundamentally what we're trying to do is empower builders to understand the fundamentals of building physics so that they can do a good job walking away knowing that they're less likely to get called back saying, oh, this has gone wrong and you don't know how to do it and can you come and fix it, which is one of the reasons why people perhaps don't move into this area because it's a little unknown. I've talked a little bit about this. This is the energy hierarchy. We'll start with energy reduction, which is essential. A lot of us is to do with how we live in our homes, improving the building envelope, renewable energy, low carbon energy, or conventional energy if you can't do any of the others. And then finally, just looking at some funding. I mentioned this already, the Green Homes grants were announced about 2 or 3 weeks ago and some more information came out yesterday. It's still not 100% clear and there's more information apparently due next week. So keep an eye out on that if you're interested. But essentially it's set into 2 sort of separate pots. There's owner occupiers and then there's people that can access it either through probably local authorities or on eco providers that might be able to do this. If you're a homeowner, you could borrow, you can get a grant up to £5,000 or a maximum of 2/3 of the cost. And the primary measures include insulation and low carbon heat. So some of you might be thinking about air source heat pumps, which is why you've joined today. So you may be able to get some support with that. A secondary measure potentially would also attract some funding, but I think there's an absolute cap at 5K. So it depends how much money you get for the first one, whether you get any for the second one. And this includes draft proofing, doors and windows, and heating controls and some sort of lagging insulation. Personally, think the hierarchy has been missed here, because really we should be looking at insulation and fabric first approaches before we offer those low carbon heats, but I'm sure all our heat pump manufacturers are really excited about this opportunity. And then local authorities will be able to offer, potentially if they get some funding, funding for fuel poverty, and this would be up to £10,000, but that has to fully fund all measures that are being installed, so the householder shouldn't have to pay for any of that cost. And private landlords can also potentially get £5,000 for doing energy improvements on any of their homes. So it's one to look out for. It's evolving, and we're hoping it's the start of something much longer term, but this is about trying to get the economy kick-started, not necessarily about completely changing the building stock. And then the existing one is the renewable heat incentive, and it covers biomass, air source heat pumps, ground source heat pumps, and solar thermal. You get quarterly payments over 7 years based on your estimated heat system. So there is some sort of suggestion that you could oversize, because you'll get more renewable heat incentive payments. You'll obviously pay more money up front, and you may have a system that is oversized for what your needs are. You will also need a valid EPC in order to get that, and that might be needing one from the last 2 years. So that's pretty much it. Fundamentally, you know, I'm coming from the perspective that if we really want to decarbonize our heat supply, we want to achieve our 2050 targets, energy efficiency is part and parcel of that process. Let's not just leap ahead to the technology. I know it's much more interesting for most people than a bit of insulation, but actually, really we need to think about fabric first approach and then look at the technology on top.